Okay, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. Good afternoon. So I hope that you can hear me clearly. Right. Okay, loud and clear. Thank you. Let me plug in my battery first. Just notice that the battery is running out. Because of today is only 1 hour, so we really need to go fast for the lecture. Right? For your information, there's no more activities lah. Alright, that's only one activity for today. So for those who cannot submit through the system through e-learning, I believe that the link now is due already. So you can submit to my email as long as you have the question. Alright, let me share my slide. I will try to use my webcam today, so I hope that I'm getting used to it. Hopefully. Okay. Alright, so today we're gonna continue with topic function. Okay. Topic function. Let's see. Alright, before that, this is the section summary, which we will cover the introduction of function, the domain, codomain, image, pre-image, type of function, injection, surjection, and bijection, inverse function, function composition, graphing functions, floor, ceiling. Okay, we will go through one by one if we have time. If not, we will continue next week lah. So I'll try my best to finish up everything. If not, we will continue next week. All right. So to introduce the function, let's say you have function x maps to y, right? Okay, we'll try to use my pen here. I hope that I can have it good. Okay, function f and function x that maps to y. Okay, this is where we have the x, which we call it domain, and y we call this codomain. God, my handwriting is very terrible. Okay, no problem. So all element in x, okay, in x is element in big X, and y is the element in big Y. All right. So when we say this, like for example, imagine that we have domain X here and codomain Y here and the element over here, right? Functions means that we map from X to Y. Maps, right? Like for example, we have x1, x2, and y1, y2, for example, where we have x1 maps to y1. For example, x2 maps to y2. So this what we call range. What is range? Range is the elements that be mapped by the pre-image. Range also called image. Same meaning. Okay, same meaning. Every element in Y is that mapped to X, okay, or mapped to pre-image. So this is pre-image, is called range. There are also values in Y which is not mapped to pre-image. So this is what we call the rest of the codomain. So range is actually the element in Y that be mapped to the pre-image. Got it? Got this? All right. So this one is clear. There are lots of terminology, but remember the big picture. So this one I've already shown to you, X1, Y1. So range is a part of codomain. Range is all the things that F can take elements in X2. Let's see the example of this one. Fx equal to X2. Okay. Oops. For example, we do have got element 2, 1, 0, -4, like this. And let's say X, we have set of X such that X is Z. Z means integer, okay? Z integer. So integer including 0 and also negative number All right. What will we have? See the function fx equal to x2. If let's say we also have y such that is y also integer, so everything is in here. So 2 maps to 4, 1 will map to 1, -4 will map to 16, and 0 to 0. Okay, let's say we have this one. So see the pattern in here, which we have positive number. So integer positive number, we can say it as W, or whole number. So instead of having y such that y is integer, we can also say that we can change it to y such that y is W, okay, whole number. Because some books say natural numbers include 0. Some books say not include, but whole number include 0. Okay, whole number is a natural numbers include 0. Okay, all right. So that's why it's just a terminology for y. Okay. Let's say if under y we have number 3. Okay, 3 is basically whole number, isn't it? Positive natural number 3. Is 3 is the image of x? Can it be the image of x? Let's see if we have this function x squared. But if we want to map it back to x, we should have it square root of x. So if let's say x is equal to 3, so when we map back to x, it should be not should be what? Square root of 3?
It won't be a whole number.
Yes, whole number. Is it whole number?
No,
No. Is it can be integer? No.
no, no.
Okay. But at the beginning, we have x is an integer. So for this whole number is just codomain but not range. So this is what we call there are elements in Y which is not range or image. It is just codomain. So that's the difference between codomain
And
and
range.
all right. Very good. Okay. This one. Oh, again the same thing. All right. So some introduction. This is I think this one is already posted in your slide, right? So I think we just keep this one. Can we just see? If we have this one, right? Okay. The codomain, and there's a element that not be mapped by the x. So the range is only A, B, C, F. Range is A, B, C, F, which is also said as image. And Adam, Chow, good friend, Rich, and Stevens are the domain, or we call it pre-image. Again, the same thing in the function. This is also similar things that I have explained before, and this one is also the same because this is just define the image, pre-image, and all that. Right? This is the function where we map from x to y. What is this? Okay, this is the same example like before. Just skip this. Can we representing function? This one is okay. We can represent function as a formula. We can represent function as explicit statement as well as computer program. But usually we use formula, right? Usually the question will give you formula. Okay, questions here. Example. Check. In this example, we do have A that map to B, okay, with the function A. So the image of D, this is pre-image, the image of D is Z. The domain of F is A. This is the domain of A. The codomain of F is B. This is the every single thing. So means that it is asking you the codomain. So the codomain is basically you write it B lah. No need to write the elements, every element of it. Right. The pre-image of Y is this is image. The pre-image is go back to the left is B. I think this one is also simple. Question on functions and set. Okay, if let's say given to you set, the set is the list of everything, the list of the element. So if let's say you have function A mapped to B and S is a subset of A, right? So for function A, B, C, function A, B, C, so we just need to see the range of A, B, C. The range of A, B, C is only Y and Z, right? Y and Z. So the function C, D, C and D is only Z. So the image of this function C and D is only Z because it has the same value. Okay, we move to injection. Any questions so far? You can just directly unmute your mic and ask if you do have questions. If not, we will just continue.
A small question, Doctor.
Mm-hmm.
The way you write the functions, if parentheses x, that is how I know it. That is, I saw a new way to write it. If اسمها ايه parallel dots x, or I saw a new maps to b. That is
Uh-huh.
another way to write functions.
Are you asking how to write the function, isn't it?
No, I'm right. Yes, the new way. That's the new way.
New way to write function.
If you go back to slide, like one slide, yes. If you
This
look,
one?
yes, f two parallel dots a. That's a function, right?
Yes.
Mm-hmm. It just it looks new to me. I'm
No,
used
no, this
to
one
the
is just
f
to show
parentheses.
A map to B only because it doesn't show the formula. If let's say you have formula, you can have fx equal to x square or equal to x plus 2 or equal to something, formula something.
Oh, it is just explanation, not the
Yeah, just
formula.
explanation. This one is showing maps to
Uh
okay,
huh.
A to B.
Great.
So okay, right? You
Tamam.
got it?
Good.
No problem. Okay. Anything else before we continue? Injection. The definition of function f is said to be 1 to 1. So the keyword for injection is 1 to 1. Sometimes people write 1 dash 1, but usually we spell it out lah, 1 to 1. Or injective if and only if, or we write it if and only if FA equal to FB. Okay, like injection, when we take medical injection, only one injection per patient, right? So same goes to this. Only one value in image or range will be mapped by one value from A. Okay, from the pre-image, see only one value. Okay. Of course, in this domain, can go out once, okay, can map to something only once. But this is basically about the image. All right. So that's the keyword 1 to 1. It doesn't matter whether in this codomain has elements that left behind. Like for example here, V not be mapped by any value in A, right? So the codomain is everything, but the range is only 1, 2, 3, 4 values. So that's for injections. Easy is 1 to 1. The suggestions, okay. What I can say here is that the keyword here is codomain should be equal to range. Means that none of the codomain value or element left behind. Every single element in codomain is actually range as well. So this is what we call suggestions. Right? Before this, we have injection. But this one, we have suggestion. That's number one keyword. The second keyword is that the criteria lah. The second criteria of suggestion, it can be mapped by one element under B. Okay, one elements under codomain can be mapped twice or triple, more than one time. Right? So that the difference lah between suggestion and injection. Right. It's like repetition lah in range. as well as every single elements in codomain is range. Okay, that's for surjection. Okay, let's see this exercise. The first one, this is the examples of different types of correspondences. This A, it shows 1-to-1, but not onto. Onto is surjections lah. Oh, I forgot to say the name. Okay, 1-to-1 and onto. Okay. Not onto because why? Because there is an element left behind. Okay, there's element which is not range. Here. For B, it is onto. Why? Because every single element in here, codomain is equal to range. Codomain equal to range. So it is onto, but not on one, not 1-to-1, because one element under codomain be mapped twice. Okay, be mapped twice. So it is onto but not 1-to-1. Next, in example C, it is 1-to-1 and onto. Why is that? 1-to-1, okay, check the criteria. It's mapped once, yes, and onto because every single element is mapped by the X, okay, by the domain. All right. Example D. Example D. Yes, this is bijection. I haven't moved to that yet. Thank you. We'll see. All right. For D, neither 1-to-1 nor onto. Why? Because, okay, 1 is left behind. So this is obviously not onto. And also it has, it is mapped twice here. So, all right. And example E is not a function because we say the domain, one of the element in domain map twice. Okay, it cannot be. So these are the examples of different types of correspondence. Now, bijections. Bijections is actually this one. Okay, when you have both criteria, 1-to-1 and onto, this is also called bijective function. Okay, bijective function. Easy. Okay. Once you grab the criteria of 1-to-1 and onto or surjective, you will get bijective function. Okay. Why I can see so active and in chat box? Is there any questions then? Okay lah, later I will try to respond. Okay. We finish with bijections. Okay, any questions so far? No questions?
How it's going to implement the question? How are you going to put it in questions?
How? What?
How are you going to put it in questions? If we are in an exam, you will put an explanation or pictures, and we will determine if it's injection or surjection or bijection.
Okay. You're asking about question. Usually the questions type is basically similar to tests or like assignments like that. Okay, this is just explanations. Previously, if you have face-to-face final exam, we usually not giving questions like explanations, details, the what we call it, that require you to explain. However, because of this COVID and we only have online mode, so we might rethink on that as well. So how to say, we need to add up a very creative questions, not to say creative, but we need to have
Different.
yeah, more types of questions lah to be answered by you all. I'm so sorry about that, because this is the best approach that we can give for online exam.
Yeah,
Okay,
yeah.
that's
Yes.
why the explanation is, I would say, important for you to really understand, so that if let's say the question out like, okay, explain this with the help of figures, then you may need figures of yourself lah. Okay.
Okay.
All right, thank you.
Thanks.
Explanation, as long as you understand, you can explain with your own figure. That's fine with me.
Hello, Assalamualaikum, ma'am. So, ma'am, for the injective function, we know it will be 1-to-1, and subjective, it should be on to, right? That's
Yes.
how we will find. Okay, thank you, ma'am.
Yeah. Mm-mm. Okay, next example showing that f is 1-to-1 or onto. Okay, suppose that you have function a that maps to b. To show that f is injective, show that if fx equal to fy for arbitrary y at arbitrary x, y element of a, and then yx equal to y. So this is just to show the function 1-to-1 or onto. Let's see the examples. Okay, example 1. Let function f be the function from a, b, c, d. Okay, from a, b, c, d, 1, 2, 3, 4 element to 1, 2, 3 that defined by 1, 2, 3 that defined by fa equal to 3, fb equal to 2, and fc equal to 1, fd equal to 3 again. Okay, see, 3 is repeated, all right? 2 times is used. So is f is onto? Yes, of course. Yes, onto. Because every single element in the codomain is used. That's number 1. Okay. It doesn't matter if it is used twice, triple time. Okay. Make sure it is everything in the codomain is also the range. Clear cut. Example number 2 is the function fx equal to x square from the set of integers, the set of integers on 2. No. Why? Because if let's say we do have f is not on 2, because there is no integer x with x square equal to -1, for example. This one is 2. Okay, right. Clear with both example? Okay, we move to inverse function. I think that one is also in your slides, right? Okay, inverse function, I also put up inverse function in the slide. All right. Definition, let f be the bijection from A to B. Then inverse of f is denoted by f -1. Inverse of f is the function from B to A, right? So it is inverse like this lah. From this is the first function from A to B. So the inverse should be from B to A. So the element under this function should be B, and this one, the element should be A. Right. The second criteria is that no inverse exists unless f is a bijection. Remember, the bijections is it should comply with 1-to-1 and also onto. Okay, so here we need to look back at the criteria of bijection, which is 1-to-1, which is 1 means that one pre-image should have only one image. One pre should map to one image. Number one criteria. And second is range equal to co-domain or vice versa. All right. So just remember like this lah. So this is called inverse function. That's it. So this is the example of inverse function where you have A, B, C, D and then map to B where the element is also 4. So C, somehow the element should also be, no. Yes, the element numbers of element is same, right? The cardinality, remember? Cardinality of A and B is same. Oh, my handwriting is so bad. Sorry, my first try. The size of A similar to the size of B. Oh, my handwriting is so bad. So this is the example of inverse function. The size of to A. And also see the arrow also from left to right. Okay, what else to show? Go to questions, example and solution. Let be the function from ABC 1, 2, 3. See the cardinality of this set and this set is similar, right? 3 elements and 3 elements, such that FA 2, 3, and 1. Every element in the second set is used once. So of course it is invertible. Okay, easy questions. We go to next questions. Stop me if you have question. Second questions. Example 2. Let function z that maps to z be such that fx equal to this formula. So this is the way you presenting the function. Okay, use formula. Okay, one of the way to presenting the function. So if f is invertible, and if so, or is f invertible? If so, what its inverse? Okay. Remember when you have function f x equal to x plus 1, fx is also we write as like this, can?
Y equals x minus 1.
Yes, correct. Now I just want to show you the step how to write it. X plus 1, then you get x to y minus 1 easy, or you write it x equal to y minus 1. So this would be the inverse function of x. Oops. The inverse function of x. All right. Finish that. Yeah, questions. Example 3. Let function r maps to r be such that fx equal to x squared. Is f invertible? And if so, what is its inverse? This one is also similar. They give similar examples. The function is not invertible because it's not 1 to 1. You can find it. Like for example, if let's say we can take f negative 2, this one is also negative 2, you may have answer 4. And if let's say a function for x equal to 2, also you may have the answer 4. So this is not invertible because it is not fulfill the the criteria of bijection. Remember? Okay, so this is not because it's repeated, got repeated value here. All right. That's the end of question example 3. Any questions so far? Okay. There's another 10 minutes, so I'm planning to discuss on questions on the class activity 3. Can we? So this one, composition, I will continue next week. Just few more slides lah. But the explanation is quite long. So I will just continue that next week. I will probably discuss with you. I want to discuss the answer for this one. Class activity. Okay. Stop sharing first. Domain or vice versa. Okay, please look back at the questions. Okay, share this content. All right. Let we discuss about the questions number 1. Okay, the question number 1 where we have question A. Determine whether these statements are true or false. Okay, when you have empty set element to set with empty set, so this is true. First one, A is true, simple. B is B is also true. Why? Because imagine that if let's say we have Venn diagram, like you have empty set with another set with empty set, which is equal to, or the element, sorry, this one is the element of this one, so it is true. Let's check C. C, the answer is false. Because why? This is to tell the relation. Like for example, if you have empty set, okay, which is the element of empty set as well, you are not this is not the element, it is just empty set that equal to empty set. So this is what we call relation. C, false. D is true. Why? Because if you have the empty set, this is the element of the set of empty set. Sorry, this one is the empty set. This is the element of empty set. So this is, see, the element of empty set. This is the set with empty set, or D. E is true because when you have, this is a proper subset, when you have the notation like this is a proper subset where you have the set, the set with empty set. When you have the empty set, is proper subset of the big set where the element of empty set and also the set with empty set. So this is the proper, this one is proper subset of the right hand side. That one is for E. For F, this is also true because when you have a set with empty set, this is a proper subset for the big set, and you have one set with empty set and another element is empty set, which is here lah, which is here. So this is a proper subset of this one. F. G. G is false. Why? Because when we have a set with empty set and you wanted to say this is a proper subset for the big set which has two empty set. Okay, so actually this one we wanted to write like this. Okay, it is, if let's say if we rewrite it, it's just one set with two empty set. This is just equal to set with empty set because both are empty. So equal means it cannot be proper set. Okay, when it is equal means it is cannot be a proper set. This is what we call just relation. But if let's say you wanted to say one if section and like for example is a subset of set with two empty set, then this is also because the question is why? Proper because subset. Imagine so that this is false. If let's say but if let's say the question asks you Venn diagram, right? Subset, you have this one, then it is empty set. Okay, empty set. Finished that one. Another set with empty set, the next, which is equal to. Ada masa lagi tak? Sikit lagi. Okay. Find the symmetric difference of the set of first one. A is true, simple. B is if let's say we have Venn diagram, right? Is empty set with another set with empty set, which is equal to. Oh, okay. If you want to have the symmetric difference, this one is the element of this one, so it is true. Let's check C. So this should be A minus B. If let's say you want to define A on only computer science, if you want to define only computer science, means that A minus B. If you only want to define maths, it is means that B minus A. So if let's say the question asks you find the symmetric difference, which is A plus B, so what you should have is that every single A minus B union with B minus A. Then you may have the answer, which is the question is asking only computer science student plus mathematics student. So the student cannot be computer science and mathematics or mathematics and computer science. So that's why we have the minus. All right, that's the end of the class. So anything that you wanted to ask, just post your questions direct to the forum link that I created yesterday. So thank you for those who have already posted questions. I remember that I need to also discuss about one question, but since we have no time, let let's move that to next week class, or else just post your questions in the forum. I will try my best to.
Ma'am, will there be any lab for or tutorial for this week, or it will be
This
started
week,
from
no,
the next week?
no need.
So there will no in Friday as well, right?
Yes, because we still we keep receiving students, and the admin still managing the list of grouping. So we will have next week, similar to the other class as well. All
Okay,
right.
ma'am. Actually, I will have a surgery on Friday, so that's why asking.
Sorry.
Ma'am,
Again.
I will have a nasal surgery on Friday, so if there will be no lab, so I can go with the surgery. So that's why asking, ma'am.
Okay. All right. But for your lab, for not like a tutorial, we don't have lab. For tutorial, this will be taught by teaching assistants. We will be having one teaching assistant as well. But if let's say we don't get teaching assistant to assist me to teach you what to do, I need to teach myself lah. All 6 hours. Okay,
Okay, ma'am.
for the
Okay.
tutorials. Okay, I hope that we can, if let's say we fail to get one teaching assistance, we will try to rearrange back lah the schedule whatsoever, so that I can have only few classes and combine few of you lah to be in one group. Let's see later. Okay, let me check with the
So,
admin.
ma'am, you are saying that if there will be no teaching assistant, then maybe you will take all the labs together in a one class,
No,
something
no,
like
no,
this.
not together in one class. No, at least three class, 2 to 3 class. Not
Oh,
everyone.
instead of five labs. I understand.
Yes, I'm thinking that way. If let's say I don't get a teaching assistant, okay.
Yes, ma'am. So it will be beneficial for you to take all those classes, five same classes. Yes, ma'am.
Okay. All
Thank
right.
you, ma'am.
Okay. Thank you very much. Thank you for your time spent with me today, and have a nice day. Have a nice lunch. Bye. Assalamualaikum warahmatullahi. Element of set you have, let's say, why? Because imagine that if let's say we have Venn diagram, like you have empty set with another set with empty set, which is equal to, or the element, sorry, this one is the element of this one. So
New Nivea Men deodorant with superior 5 times protection, anti-stain, and a masculine scent for ultimate confidence.
This with no elements inside it. Like the set of sensory organs of your book is a non-living thing and does not have ears or eyes. The same. And if you're asked about the set of sensory organs of a human being, anyway, the null which cuts across. Now think about it. Is the null set a subset of the set A? Yes, the null set is a subset of every set. But why do we say this? There's actually a funny funny way to understand this. You can look at it this way, that nothing is a part of set A too. And that's why we say that the null set is a subset element of nothing. And this is also obvious as we know that every set is a subset of itself.
Parti untuk satu KFC The One Box. Tak payah beratur dengan KFC Self Collect.
Hello everyone, welcome to Raffle Quest. Why is that? Well, set A, the empty set, is always a subset of the subset of any set. Why is that? Well, that's what I'm saying. A, which contains 1, 2, 3, and 4. And that's the more important part. AL set of B. Subset of another set is identify an element that it has that is not in this other set. Have not in a case that would disqualify it from being a subset of any other set. Well, of course not. It doesn't have any elements in it. So of course
1, 2, 3, 2, and that we learned can say have a symbol to represent set of N is P, a subset of Q. Set P is a subset of set Q when every element in P is also present in Q. Look at the element, but this statement raises a new query. Look at sets C and D. Set C has 4, 5, and 6 as its elements, and set D has 4, 6, and 5 as equal. Set D is a subset of itself. P is a subset of P. Q is a not C. Look at sets one element in set Q which is not present in set P. We say that set P is a proper subset of set Q. This sign indicates proper subset. And this tells us that all elements of P are present in set Q, but there is at least one element in Q which is not present in P. We can see that 4 and 5 are not present in P. So that's the concept of a proper subset. Sometimes it is also referred to as the strict subset. Can we say C is a proper subset of D? Think about it. That would be incorrect since there is no element in D.